Hello guys and welcome. In this video I'm going to talk about mirror networking. So in the previous videos about networking for beginners, I talked about the role of master server and game server. So basically clients are going to connect to the master server for authentication, matchmaking and other stuff. But for the actual gameplay simulation, they're going to connect to the game server, which in order to build the project for the game server, we could use packages like netcode for game objects, mirror, and other packages, which in this video we are going to talk about mirror networking. So basically in mirror networking, we can write the code for both client and the game server on the same project. And at the end, when our project is complete, we're going to get two different builds, one for the client and one for the server. So let's actually go ahead and cover the basics of mirror networking. So I've created a new project. The first thing we need to do, we need to import the mirror package, which you can go to the GitHub repository, and in the releases you could download the last version available. And it is available as a Unity project for you, so you could just simply download it and import it in your project. So I've already imported the mirror. Also, I have two animations. One is just a simple idle and one is running, and an animator which has a parameter called movement and a simple blend tree called movement, which has these two animations. And by simply changing the movements to 1 and 0, we could move our character animation. It's something really simple, nothing complicated. And also I have a model in my project that I'm using. So other than that, everything is just a brand new project. So we have a default scene, which I'm going to rename scene with index 0 menu. And I'm going to duplicate this. Let's create another scene, index 1, let's say map 1. So here in the menu scene, I have created a canvas which has a simple image as background and two buttons, one for start as server and another one start as client. It's just something simple, nothing complicated. So basically, when our project is ready to be published, we're not going to have two buttons to start as server or start as client. Instead, we are going to have two different builds, one for the server and the other one for client. And let's actually go to the build settings. The build we're going to publish to our users is going to be either Windows, Mac, Linux, or Android, iOS, whatever. And the build we're gonna actually upload on our game server, we're going to use dedicated server build. And when we're building for the server, it's gonna automatically start as server. And when we are building for clients, it's gonna automatically start as client. So this is just for the demo, these buttons, and it's just for testing the package. So I have my main menu, which has two buttons. So the idea is we have one menu and we have multiple maps, and when the server build starts, there is nothing server needs to do in the main menu. It's just going to jump into one of the maps that has already been defined for it. So that's for the server. And for the clients, whenever they start, they're going to first see the main menu, and then here they're gonna do their authentication, their matchmaking, maybe their lobby rooms, whatever. And then when they select a certain map or they were matched into a certain map, they're going to connect to the server that is running that map. And then they were going to be transferred to that scene and they can play the game. So let's actually add our scenes to the build settings. I'm going to add the menu as the index 0 and the map as index 1. So that's it. Now we need a script to handle our menu scene. In order to do that, I'm going to create a folder called scripts. Inside here, create a script called main menu. Also, I create another script called connection manager. So our connection manager, I create a game object called connection manager and attach that script to it. And for the main menu, I could just attach it to my canvas. So that's it. Now let's open our menu script. So we have 2 buttons. We're gonna create a method for on server clicked and another one on client clicked. And inside the start, we're gonna add the listeners for them. Server button on click, add listener on server clicked, and for the client button on client clicked. If we take a look at here, I've added an extra condition here, which is going to check if it is not Unity editor and it is Unity server build, then it is automatically is just gonna run this method on server clicked and returns. So the reason I've added this, let's actually go to the editor. Let's take a look at the build settings. So when we are building for the dedicated server and when we run that build, it's actually going to look something like a command prompt. So it's gonna look something like this. So there is no buttons. Actually, when you are building for dedicated server, the UI is gonna be removed, the shaders are gonna be removed. Basically anything visual is going to be removed in order to increase the performance, because server doesn't need to show anybody anything. It's still going to do all the calculations, all the movements, transforms and animations, everything, but there's nothing visual about it. So the reason is to remove graphic card from the server, and server is just going to rely on RAM and CPU and basically doesn't need a graphic card, doesn't need a GPU. So when we're building for the dedicated server, then if we run that, it is going to call on server clicked automatically. Now let's go and take a look at the connection manager. First, I am going to create a singleton for it. And here in the awake, we assign that singleton. Now I will create an enum. So to determine whether we should run as client or server. And then I'm going to create 3 variables, IP, port, and type. And then I will create 2 methods here. One of them is going to be initialize as client, the other one initialize as server. For the server, it's just gonna take a port, because when you start as a server, you're gonna start on your local IP, and when you start as a client, you need an IP to connect to and you need a port to connect to. So you're gonna assign the variables here, these variables. And here in the main menu, when we say server clicked, we're gonna call the connection manager singleton, initialize as server, and we're just gonna pass the port that we want our server to start on. So I'm just gonna pass something here for a demo. And when you start as the client, you are going to call connection manager singleton, initialize as client. For now, we're just gonna pass the local IP and the same port. And in both cases, we're going to move to the scene index 1. Basically, we're going to move to the gameplay scene. So basically, when we open the project, first let's actually assign these buttons. That's button server, button client. So when user opens the menu, whether you are the server or the client, you are going to store the IP and port inside the connection manager. So for the client, we store the IP, port, and the type, which is client. For the server, we're gonna store port and type, which is server. They're gonna be stored here, and since we're not destroying this connection manager instance, the connection manager instance will go to the next scene with us, and we're gonna use these credentials in the next scene to either start as a server using these data or connect to the server using these data. So let's go to the next scene actually on map 1. So here we don't need a background, we don't need a button, we just need a button quit. So that's it. And I'm going to assign this button to my game menu. For now, let's just align it somewhere here. So that's it. Now let's go ahead and create a script here and call it game menu. So we can attach the game menu to our canvas in the map scene. And quickly, let's go ahead and create our quit button. So we can also create a method for it. Let's say return to main menu, and inside the start, we can add the listener for it. So here we can assign the quit button, and that's it. Let's take a look. We have stored our data inside the connection manager. Now we are in the map scene. So the first thing we're gonna do, we're gonna use those credentials using game menu script and either start the server or connect the client. So in Unity, using mirror, everything happens through a component called network manager. So I will create a empty game object in our map scene, and I'm just gonna name it network manager. So our network manager is also going to need a transport. Usually using mirror, we are going to use a KCP transport. So we're going to add that to our game object. And here for our transport, I'm going to drag this into this field. Now we are going to go to our game menu. The first thing in the start, we're going to access our transport. And since it's attached to the same game object as the network manager, we're gonna get the component on that game object. First, we're gonna assign the transport.port to the same value on our connection manager singleton connection port. Then we're gonna check the connection manager singleton connection type. If it is the server, then we're gonna use the network manager singleton to call start server. And if it is client, then we're going to first assign the network manager singleton network address. This is basically the IP address to the same value we've saved inside the network manager. And then we're gonna start as client. And inside on destroy, we're going to stop the server if we are the server, or stop the client if we are client. So this way our connection is going to be established. The next step is actually to have a player in our scene, basically a player character or a game object, whatever. So to do that, I will create a plane as my ground, and here I will create an empty game object, name it player. So for our player, I need to bring in my model. So I've already have a model ready. And for the model, I will also assign the animator, which I've already showed you. It's not something complicated. It's just two animations. So this is our player. So whenever there is a player, there should be a script called player controller. So we need to synchronize the position of our player with all the clients and the server. So basically every time we want to do something like that, something network related on a game object, we need to have a network identity on that game object. We're going to add network identity to the player, and for the player controller, since we are going to write network related code, instead of mono behavior, we're gonna inherit from network behavior. So the first steps is to create a move speed for our player, get a reference to our animator, and also have a variable for input. In the awake, we're gonna get the animator, and we're gonna do our movement logic inside the update. Let's take a look at the editor. Our player should have player controller on it. And since we're going to synchronize the position of this game object, which is our player, so basically whenever you want to synchronize the position or rotation or scale of any game object, you are going to need to attach a network transform to that game object. So I'm gonna attach a network transform reliable. You could also add unreliable. I talked about reliable and unreliable type of networks in the previous videos. So basically here you can check whatever you want to scale, rotation, and position. And whenever you want to synchronize the animation of an animator over the network, you need to attach a network animator. And you also need to assign which animator you want to synchronize. Here, that's our animator. So that's our player character for now. Let's go to the code. In mirror networking, every object that has a network identity on it is either owned by the server or is owned by one of the clients. So here in our code, first we check if this game object, this player, is owned by the local player. If it is, I'm just gonna get a simple input, and if the input has actually changed, then I'm gonna do the movement. So as I mentioned in my networking videos, there are two ways we could do different tasks in multiplayer games. We could either give the authority of that action to the server, or we can give the authority to the client. So here we're going to move the character around. I'm gonna actually do both. First, I'm gonna write the code to move the character with the server authority. Then I'm gonna write the code to move the character using a client authority, the client that actually owns that character. In order to invoke a function from a client on the server, so you're on the client, you want to call a function which you want to be executed on the server. We're going to use something called command. I'm going to create a function called cmd move, and I'm going to give it the tag command. So this is going to be run on the server. Whenever you call it on a client, this is going to be run on the server. So here, you are the owner and you are the client. Then you're going to call cmd move, and before that we're going to assign the input to make sure only we call cmd move when a change happened in the input. So we're going to pass the variable input, and here inside the cmd move, first I'm going to assign that. Second, I will create a float movement to be passed to my animator. Basically, whenever our character is idle, the movement is 0. When it is moving, the movement is 1, and that is going to be passed to the animator. I'm going to create a move direction using the input, normalize it, and just simply move the character with it, and also rotate it toward the direction of move. So all of this is going to be happen on the server. Now that's our player controller. So I will create a folder, call it prefabs. So inside this prefabs, I'm gonna drag my player, and we can go ahead and delete that. So on our network manager, if we take a look, there is a variable called player prefab. So I'm gonna assign this to this field here, and there is a checkbox auto create player. So it's basically going to create this game object for each client that is going to be connected to the server, and the owner of that game object would be the client. Now if I save this, and also note something on the player here on the network transform, if we take a look, the sync direction is client to server, but since we wrote the code to be executed on the server, we need to change the direction server to client, because movement is actually happening on the server, and we want the server to tell the clients what the position is. The same thing for the network animator, it should be server to client. So that's it for our prefab. Let's actually get a build. So in the player settings, I will make it windowed for the test. Also for multiplayer games, we check run in background. Now that's it. Let's take a build. Here we go. Select folder. So here it is. Build is complete. I'm going to run this. One instance, and let's run another instance. We have 2 instances of project. One I'm going to start as server, and the other one I'm going to start as client. You see that immediately a character will be spawned for the client. I can move around, and both position and animation is being synced. but I think I should have removed the condition in the input. So let's actually go and fix that. Here in the player controller script, we could just get rid of this condition and call cmd move constantly. So basically that's movement with server authority. So let's do the same thing using client authority. We no longer need this. We no longer need cmd movement. So in the update, we get the input, and we're gonna define the float here, create a move direction based on input. If move direction is not 0, we move the transform and we rotate it. Also assign movement as 1 and assign the animator. So that's it. Everything is happening on the client, on the owner. We're not calling cmd move or anything. Nothing is being executed on the server. Actually, it's all being executed on the client. And we go to our editor here on our player, in the prefabs player, in order to synchronize the network transform. We're gonna synchronize from client to server. Basically, client is making the move and tells the server, this is my position. The same thing for the animator. It's going to be synced from client to the server. So if I get a build for, it should give us the same result. So let's run this, and also another one. Now if I start this as server, start this as client, you can see if I move around, everything is being synchronized. I can quit, start again as client, quit, client. Works fine. Another instance as client, or 2 clients. So everything works just fine. So basically, whenever you want to send RPC from a client to the server, you use command. Whenever you want to send an RPC from the server to the client, you use client RPC. So basically, client RPC is for all the clients. Instead of command, you write client RPC. And whenever you want to send an RPC to a certain client, you use target RPC. Let's actually go ahead and take a look at the documentations. So we have commands, which are sent from player objects on the client to the server. So we have client RPC calls, and we have target RPC calls. So this actually, there's a lot of good info on mirror networking Gitbook. There is the documentation you could read. So basically, let's actually write 2 methods. In the commands, whenever you want to also access the sender info, you can define a variable of type network connection to client on the cmd function, the command function, and it's going to give you the sender info like sender connection ID. And whenever you want to call the target RPC, you can pass that network connection as the target that is receiving this remote action. So this is being called on the server and will be executed on the client, on this target client. And you call target RPC whenever you want to execute a remote action on a specific client, which you are going to pass the network connection of the target. So here, the network manager is automatically going to instantiate the player prefab for us. We could also instantiate it ourselves. So let's create a script called player terminal, and this player terminal also going to be network behavior. So I'm going to create a singleton for it. So every time we want to instantiate a player for a client, we're going to call spawn player from that client, and then we are going to get the prefab from the network manager prefabs list. For now, as a demo, instantiated, and using network server, we're going to spawn that player game object, and the owner is going to be the client that sent this request. So here in the start, we're going to check if it is the client, and if it is the owner of this player terminal, we're going to assign the singleton, and we're going to call spawn player command. So now if I save this, and by the way, if we take a look at the prefab, we're actually going to get the prefab for now from the network manager singleton spawn prefabs index 0, which is the first element in the prefabs list. If we take a look at our network manager, here there is a registered spawnable prefabs. Any game object that we want to instantiate in our network, it should be added here first. Otherwise, we can't just instantiate it in the network. Let's just create an empty game object, name it player terminal, and I am going to attach player terminal. We also need a network identity for it. As you can see, we got an error. Player terminal requires a network identity. Why? Because it is inheriting from network behavior, so we need to attach a network identity. So now in the prefabs, I will create a prefab for this player terminal, and let's delete that. In the network manager, instead of player prefab, I'm gonna add player terminal, and inside the spawnable prefabs, I'm gonna add the player. So now also let's actually make it a little bit more interesting by creating a script called spawn points. So the spawn points is going to have a singleton, an array of transforms called points, an integer as last index, which we are going to use it inside get point in order. So in the awake, we assign the singleton. When we call get point, is just gonna take an index, return transform inside the array on that index, and whenever we call get point in order, it's just gonna each time give us one element inside points. Something simple. And inside the player terminal here, when we instantiate the prefabs on Victor 3.0 and quaternion identity, instead we could get the spawn point, calling spawn point singleton get point in order, and instantiate it on that spawn point position and rotation. So that makes sure our clients are not going to be instantiated on the same spot, basically going through each other. So this is a game object called spawn points, and I will attach spawn points, create an empty spawn point here, call it 1, maybe duplicate this a few times, and that's 1, that's another one, this is another one. So I will assign these values to the points. Now if we go ahead and save this and get a build from our project, here we go. If I run one instance and another instance, and start this one as server, this one as client, and let's run another one. So if I start this one as client, you see they are instantiated on different spots. So this is my first client, this is my second client, everything is synchronized and working just fine. So this is the basics of mirror networking. It's actually very simple, and you can build any type of multiplayer game using this package. I'm gonna finish this video here. I hope that you enjoyed it and it was useful for you. Please make sure to like the video and subscribe to the channel. Thank you for watching.